How to draw an isomer. So the definition of an isomer that you need to know is molecules with the same molecular formulae but different structural formulae. And the example that we're going to look at is the molecule butane. So the formula of butane is C4H10, and the carbon atoms can be arranged in two different ways. For example, if we make molecules of butane, just showing the carbon atoms, there are 4 carbons and they can be lined up in a row, 1, 2, 3, 4. Or just showing the carbon atoms in this molecule, you can have 3 in a row, 1, 2, 3. And the 4th carbon atom is a branch. So this one here has got 1, 2, 3, 4 in a row. This has got 1, 2, 3 in a row. So if we add our hydrogen atoms to the carbon, we have this molecule here, and we have this molecule here. And then if we draw these out on paper using carbons and hydrogens, this molecule here looks like this. And this molecule here, underneath that carbon, there's a hydrogen that you can't see, looks like this. And these two molecules are isomers of each other because they've got the same molecular formula, C4H10, but they've got different structural formula, i.e. the carbon atoms are arranged differently in this molecule compared to that molecule. One of the things that you do need to be careful of, however, is thinking that this molecule here is an isomer of this molecule. Although this has got a bend in it, it still has 1, 2, 3, 4 carbons all joined together in a line, and this has got 1, 2, 3, 4 carbons all joined together in a line. So this molecule is actually the same as this molecule. If we look at a different example, an alkene, for example butene, this is C4, there are 4 carbons, H8, there are 1, 2, 3, 4, 5, 6, 7, 8 hydrogen atoms. Butene is an alkene, which means it contains 1 carbon-carbon double bond. So in this molecule here, in this isomer, we show the carbon-carbon double bond because there are 2 bonds between this carbon and this carbon. And there are 3 different ways that you can arrange the carbon atoms in butene. There's this one. There's this one, where there's a carbon-carbon double bond between this carbon and this carbon, this bit here. And there's this version, which has got a carbon-carbon bond between this carbon and this carbon. Now if you draw these out using carbons and hydrogens, you'll see that this molecule looks like this. This molecule, the carbon-carbon bond is between those 2 carbons, that's that carbon, that carbon. That CH3 is that CH3, that H is that H. And in this molecule, the carbon-carbon double bond is there. And this CH3 is this CH3, and this CH3 is this CH3. These 2 molecules are different, and the reason they're different is because in this molecule, this CH3 is across from this CH3, and in this molecule, this CH3 is on the same side of the double bond as this CH3. So there are 3 different isomers of butene. There's this one, and this one, and this one.